One of the things that have always bothered me with the traditional analog workflow in mastering is that I often find myself in a situation where I like some of the things that a processor does, but not others. An extreme example of this could be if I'm running the mix through analog tape, for example. A lot of things happen when doing that. There is filtering in the low end, there is some sort of compression and saturation. The high end can soften a bit, and the transients can sound different. There is also added noise and wow and flutter and so on. All of this depends on a lot of factors like which tape machine I'm using, or the tape type, or the calibration, and how hard I hit the tape, and so on. But some of the things are good for the song, and some of the things are not good for the song. And that kind of depends on the situation. And there are similar things happening for pretty much any type of plugin or hardware that has some sort of character. So over the years, I have looked for alternative ways of processing sound that can give me more control and let me isolate specific behaviors. Then I can choose exactly what kind of changes I want to the sound instead of relying on processors that does a lot of things all at once. And in this video, I want to demonstrate one of these methods. It is a way to use saturation to add more density or texture or clarity to the sound without some of the common problems that you can get when using saturation on a full mix. So we're going to add saturation to a specific frequency area, and to do this we will also make use of the delta signal. And this is also opening up to a more modular and intentional approach to audio processing in the digital domain. And I think this approach is a great addition to the more conventional gear-based analog workflow that is very common in music production. My name is Thomas, and I run this channel together with Sofia. We have both spent many years mastering records, and on this channel we share what we have learned to help you make better sounding music. So let's start with an example. Saturation can be a bit tricky to use in mastering. It can be very useful for individual sounds within a mix, but when adding saturation to a full mix, I often find that any amount of it is usually either too little or too much. It's very easy to get this sort of very crunchy sound, or something that isn't really affected by the saturation that much. So the sweet spot for using saturation on a full mix is often quite small. And one way to deal with this is to only add saturation to a specific frequency area. And this is what I'm doing here. And I'm going to exaggerate the effect now to make it easier to hear. And if I move this frequency around, you can hopefully hear that different parts of the spectrum gets this added crunch or crispiness. It's almost as if a spotlight is moving across the spectrum and highlighting the different parts. And this effect is done by creating what's called a delta signal. That is essentially the difference between the output of a processor minus the input of the processor. So it's the thing that the processor is actually adding to the signal in order to get the effect. I will talk a bit more about the delta signal in a while. And we can listen to how it sounds to begin with. We'll exaggerate the distortion a bit here. So by listening to the delta signal, we can hear exactly what it is we are adding to the clean signal. In this case, it's the generated harmonic content from the clipper. So for example, we can listen to the low end, how it sounds. I will add both the clean signal and the delta signal, so this is the full effect. So now we are effectively saturating this area here that we have bandpassed. So now this low end part of the mix is quite distorted, saturated, but the rest of the mix is left intact. So we can hear the kick and the bass are quite heavily saturated now, but it doesn't affect the upper parts of the mix. So it's a bit like isolating the compactness and fullness from tape saturation, but we're only applying it to the bass frequencies. And now I have exaggerated the effect to make it obvious and audible, but we can of course reduce the amount of saturation and also reduce the amount of the delta signal that we add back to the clean signal. So we have full control over the amount of saturation that we are adding to this frequency band. So with a more sensible setting, it would probably sound more like this. Still quite a lot of crunch, but you can hopefully imagine how this could be useful. And then we can listen how it sounds if we do this in the mids. Let's place it at a kilohertz or so. And now I will also flip the polarity of the delta signal, because you could do pretty much what you want with the delta signal as long as it sounds good. So let's have a listen to first the delta signal by itself and then how it sounds when we add it back in. So this is the delta signal, and then I will add it to the clean signal. So now this added harmonic content really helps bringing the mids forward a little bit. We get a sort of contour on all the instruments in this area. And to my ears, this sounds a little bit like the transient shaping character that you can sometimes get from some compressors when you use them on a mix, but without the actual compression. So in some cases, this kind of processing can work as a substitute for compression when you really only want the transient clarity part of the compressor, but not really the compressing part of the compressor, so to speak. Because sometimes we just want to add a certain type of character to the sound, and then we might associate that character with a certain kind of compressor used in a specific way, for example. But that will also bring with it other side effects, like compression, obviously, because that's what a compressor does. But if we just want the character, then it's sometimes possible to create the same kind of character using a completely different method, as in this case, when we're using bandpass saturation. And this is an example of working with intention in mastering. It's not about using specific gear or anything like that. It's more about having an idea about what to do with the sound and then choose the tool that helps you get to that sound. And in this case, the tool is to use bandpass saturation. And the intention is to add a bit of contour to the transients. And in the previous example with the low end, then we can think of the intent as adding a bit of density and solidness to the low end, somewhat similar to the sound that you would get from pushing analog tape, but without all the other side effects that you would get from doing that. So exploring methods like this can really be useful for shifting from a gear-based mindset to a more intention-based mindset when it comes to processing. And with this method of using the delta signal, we also get full control over how the saturation is created, and we can go from completely clean, when we are not adding anything of the delta signal, up to the full effect of the saturation. And when you use this in a tasteful way, then it can be used even on something like a clean acoustic recording, for example, if you want to add some extra fullness. And we can look at the delta signal a bit more closely. So if we have a processor, like for example a saturator, then we have an input to that processor and we have an output. And if we take the output and subtract the input, then we get the delta signal. So here I'm taking the input signal, polarity invert it, and add it together with the output. Then we get the difference between the output and the input, and that is the delta signal. So the delta signal contains only what the processor added or changed. So the output from the processor is the same as the input plus the delta signal. And this is what we can see in this diagram. And instead of drawing all of this, we can use a bit simplified symbol instead. So this simply means that we have extracted the delta signal from this processor. So instead of running the whole signal through the plugin, we can keep the clean signal untouched and then add back what the processor changed. So a gain control on the delta signal will behave pretty much as a dry-wet control. And you can also shape the delta signal by both tweaking what goes into the processor, and you can also change what happens with the delta signal itself afterwards, before adding it to the clean signal. So you get a lot more control over what the processor will contribute to the sound in the end. And in the example we listened to, we first took the clean signal through a bandpass filter, and then this bandpass signal was sent through a saturator, which we extracted the delta signal from, and then we added this signal back into the clean signal. So first we had a bandpass filter. This is just a normal bandpass filter that lets us isolate a frequency area. And then this bandpass signal goes into the saturator. And I can choose how much crunch I want to have on this bandpass signal. And then we extract the delta signal from this plugin. And in Reaper, this is very easy. You can right-click the dry-wet control and select delta solo, difference between dry and wet. Poof. And then the plugin is outputting only the delta signal. And this signal then goes through this gain control that lets us select how much of it we want to add back to the clean signal that also has a gain control here. This gain control isn't really needed. I just have it here to make it easier to demonstrate this. And to do this, I have used the routing in Reaper. I've placed everything inside a container. And the first thing I do in the chain is to split the clean signal into 2 paths. And then I do all the processing on channel 1 and 2 and keep 3 and 4 as the clean signal. So the bandpass filter and the clipper and the polarity switch and also the delta gain are all in the path of channel 1 and 2. And then the clean signal is in the channels 3 and 4, and these are then recombined at the end. So that's one way to create this signal flow in Reaper. And also just a note, when working with saturation, there are often side effects in the form of crunch or audible clipping, things like that. And adding saturation can sometimes make the signal sound a bit louder, and then it's important to compensate for that when comparing before and after, so we don't get fooled by loudness bias. Otherwise, it's very easy to miss the side effects. So that's why I'm using automatic loudness matching when comparing. And when using the delta signal like this, the mix stays completely untouched. And even though we used a bandpass filter here, the mix itself has never passed through any filters or crossovers or anything like that. And since we're extracting the delta signal from the saturator, we really don't have any filtered sound, so to speak, within the delta signal either. This filtering is sort of cancelled out when we extract the delta from the saturator itself. There is still some phase shift going on, but that will mostly affect the added harmonics. And in my experience, that doesn't really matter. The thing I think matters the most here is that we haven't used any crossovers or filtering in the direct signal path. You could use another approach where you split the signal up into different frequency bands and then process one of those bands and then recombine everything at the end. And that approach can also be useful and can sound very transparent, but it's much more difficult to set up, and it's much more difficult to keep track of the actual changes. And it's, to be honest, quite a lot easier to mess things up as well. In my experience, I get a lot more control over what I'm doing when I'm using a delta signal approach. And this is just one example of things that you can do with this approach. Now we extracted the delta signal from a saturator, but what happens if this is a compressor instead? And are there other things that you can put in front or after the delta stage? And what happens if you flip the polarity of the delta signal? There are lots of things you can do, and with a bit of imagination and testing, you can craft very deliberate and creative changes to the sound. And I think of this setup as a modular building block that I can use to make very intentional changes to the sound and still have good control over the side effects and the amount of processing that I want to add. And using the delta signal works particularly well with nonlinear or level-dependent effects like saturation or compression or clipping. If you have a plugin that strongly affects the phase, then those are often better used in series. An easy way to check for this is to listen to the delta signal and hear if it can get completely silent apart from the added effect. in this case I needed to adjust the gain of the saturator in order to fully cancel out the clean signal before extracting the delta. So the delta signal isn't useful for all kinds of processors, but when it works, it can be a very useful and creative tool. And just to be clear, the concepts in this video are not new in any way. I'm sure that there are existing plugins that work in the same or similar way that I have talked about in this video. Most plugins are internally made from smaller building blocks like this that are combined in a modular way, and delta signals are often a part of it. And if you're into sound design or creating synth patches, you're probably already very familiar with a modular approach to audio processing. And within other areas of signal processing, like image processing, similar concepts and methods are very, very common. But in music production, it's easy to stick with the traditional ways of working, where we often use effects connected in series, one after the other. And using the delta signal is more of a digital workflow. It would be quite difficult to do it reliably in the analog domain. And there is a lot more to say about delta signals and modular processing and working with intention in general. So if you have been enjoying this video and want to see more of these more advanced topics, then you should let us know in the comments and make sure to click the like button. Thanks for watching, and I will see you next time.